Okay, we're starting back up the video, and what you will need, this is day 9. This is day 9 of your learning, and it's going to be due April the 6th at midnight. So you need to make sure that you get that in by then. Exponential functions is y equal a times b to the x power. So an exponential functions are defined by an equation of the form y equal a times b to the x power. This is your b that it's talking about, and so I wanted you to make sure this is your x and this is going to be your y. So I had to study on that to remember what that meant, but this will be your b that it's talking about right here. If b, this number right here, is greater than 1, the function is an exponential growth. So all you would have to do is look at this number right here to tell if it's going to be a growth. And if it's a growth, it's increasing, means that the graph is going to go in this direction. It's increasing. If b is less than -1, if this is b, and if it's less than 1, the function is an exponential decay and is decreasing. So this is what it would look like if it was decreasing. The graph, this would be a decay. It is decreasing over time. That means it's starting out here, it's starting up here, and it's decreasing here, it's starting over here, and it's coming up and increasing. A line which the graph gets close to but never touches or crosses is called the asymptote. So if you look at this one right here, this gets really, really close to 0, but it never crosses 0. It's past 1, but it gets really, really close to 0, so your asymptote would be 0. We know that your domain is all real numbers. So let's look at the very first one. Y equal 2 to the x. Okay? So we know that b is going to be 2. So b is equal to 2. There's no a. Do you see that there's no a in this problem? And so it's y equal b to the x power. So if you made x, this little x right here, we're going to remember the table that we talked about making for every one of them. You're going to use -2, -1, 0, 1, and 2 to graph, to come up with some points to graph your line. Well, you're going to do that. So if we make b a -2, so 2 to the -2 would be 1 over 4, which changing that to a decimal sometimes helps graph it. 1/4, which is 0.25. -1 to the 2 to the -1 is 1/2, which we know is 0.5. Same thing. 0, anytime the power is to the 0 power, it means 1. 1, when it's 1, 2 times 1 is 1. And 2 to the square root is 4. 2 squared is 4. So then we see b was 2, so we know it's going to be a growth. We graph those points, and we see that it's going up like this. It's like the one right here. So it would be a growth. And we know that 2 is greater than 1. So we can say 2 is greater than 1, and that way it is increasing. We know the domain is all real numbers. We see the y-intercept where the line crosses the y-axis is 0, 1. We see the asymptote is 0 because it gets close to 0, but it never ever crosses it. You can see that it's 0.5, 0.25, and these numbers are going to get smaller and smaller and smaller, but it's never going to cross this line right here. No matter what number we put, negative number we put right here, it's never going to cross that line. And that's why we call these exponential functions. Let's look at number 2. We see that y equal 1/4 to the x power. So we see that b is equal to 1/4. Well, b is less than 1. 1/4 is less than 1. So it's going to be a decay. We know our line is going to look like this because it's a decrease. So when we put in these, when we make a table with -2, -1, 0, 1, and 2, always make your table. So you're going to say 1/4 to the -2 is equal to 16. 1/4 to the -1 power is 4. 1/4 to the 0 power is 1. 1/4 to the first power is 0.25, and 1/4 squared is going to be 0.0625. We see that we start way up here, and it goes down, and it never crosses 0. Our y-intercept is right here, 0 and 1. That is our y-intercept right there. And so you continue, so that's this answer right here. The range is y is going to be greater than 0. Our y is always going to be greater than 0. It's never going to go down in here. So y is always going to be greater than 0. And the asymptote is y is equal to 0. Okay, let's look at the next one. Number 3. We see y equal 3 to the x power minus 1. Well, our a, this is our a, this is our b. So if our b is 3 is greater than 1, it's going to be a growth. We can see that just by looking at our formula. Okay? Our domain is going to continue being all real numbers. We're going to make a table. You're going to put x and y. You can also make it x, y, like this, and put your formula in here. Y equal 3 to the x power minus 1, and put that there and you can do it either way, okay? Well, if this is -2, y equal 3 to the -2 minus 1 would give you -0.8. You can just put that into your calculator and work it. -1 to the 3 to the -1 power minus 1 would give you -0.6. Remember, when you have a negative power, you have to put it 1 over. So it would be 1 over 9 minus 1. That's what that would be. This would be 1 over 3 is what that one would be. So that's how we got that. We see that the y-intercept is 0, 0. We see that, do you see this is -1 right here? Do you see it never goes below -1? You could have put a 3, you could have put, but our line goes out right here, and it's never going to go past negative. So y is, our asymptote is -1. Our range is y is always going to be greater than -1. So our y is never going to go below -1 right here. So we know that, okay? So it's never going to cross your -1 line. Let's go to the next one, number 4. Y equal 1/3 to the x power plus 4. Well, our b is the 1/3. This is our a, okay? b equal 1/3. So if b equals 1/3, 1/3 is less than 1, so we know it's going to be a decay. That means our picture is going to look like this. Now we're going to see what line you use. You find your x's and your y's. Put your x in place of your little x right here. 1/3 to the negative 2 power, just going to be 3, would be 1/9, 9, so it'd be 1/9 to the negative, so it'd be just 9 plus 4 would be 13, and that's where you got that. This would be 7, because it would be 3 plus 4, because you just invert it because of the negative. 0 and 5